Hello viewers, in today's class we are going to take up one important definite integral, right? So here we have to integrate this function square root of 10x plus square root of cot x from 0 to pi by 4. So let us call this integral as I, right? Okay, now let us write this function as square root of 10x can be written as square root of sine x over square root of cos x, right? And square root of cot x can be written as square root of cot x divided by this is cos x divided by square root of sine x, and here we have dx, right? Okay, now we can take the LCM, and this integral reduces to 0 to pi by 4, and if we take the LCM, so here we have a square root of cos x, sin x, and in the numerator we have sin x plus cos x, right? Okay, so now once we have obtained this function, we can now integrate it by method of substitution. So now let us substitute t is equal to sin x minus cos x, right? So here we have substituted t is equal to sin x minus cos x, because the derivative of sin x minus cos x is sin x plus cos x, right? So we have changed the variable from x to t, so dt over dx is equal to cos x, the derivative of sin is cos, and the derivative of cos is minus sin, so here we have plus sin x, right? So now this can be written as dt is equal to cos x plus sin x dx. Okay, so now for this term we have dt, right? Now let us express cos x sin x in terms of t. Now for this we'll consider the square of sin x minus cos x, right? So the square of sin x minus cos x is equal to sin square x plus cos square x minus 2 sin x cos x, right? So here we have expressed we have to express cos x sin x in terms of t. So now we have considered the square of sin x minus cos x whole square. So here we have applied the formula of a minus b whole square. So this is a square plus b square minus 2ab, right? Now sin x minus cos x is t, so here we have t square, and sin square x plus cos square x is equal to 1 due to the identity, and here we have minus 2 sin x cos x, right? So now this can be written as 2 sin x cos x equal to 1 minus t square, and sin x cos x is equal to 1 minus t square over 2, right? So sin x cos x, the product of sin x and cos x is equal to 1 minus t square over 2, right? So now let us change the limits accordingly, because the limits are from x equal to 0 to x equal to pi by 4. So when x is equal to 0, let us write it here. When x is equal to 0, then the value of t is sine 0 minus cos 0, and sine 0 is 0, cos 0 is 1, so we have minus 1, right? Similarly, when x is equal to pi by 4, then the value of t is equal to sine pi by 4 minus cos pi by 4, and sine pi by 4 is 1 over square root of 2, and cos pi by 4 is 1 over square root of 2, and this is equal to 0, right? So when x goes from 0 to pi by 4, then t goes from -1 to 0. So viewers, now this integral can be written as when x is equal to 0, then t is equal to -1, and when x is equal to pi by 4, then t is equal to 0, right? And sin x plus cos x dx is equal to dt, and divided by square root of cos x multiplied by sin x is equal to square root of 1 minus t square over 2, right? Okay, so now we have obtained this expression. Now this can be written as I is equal to -1 to 0, and taking this square root of 2 to the numerator, so we have square root of 2 dt, and divided by square root of 1 minus t square, right? So now we can write it further as the square root of 2 and -1 to 0, and here we have dt over square root of 1 minus t square, right? Now here we will use the well-known result which says that the integral of 1 over square root of 1 minus x square is equal to sine inverse x. So here the variable is t, so we can write square root of 2, and the integral of 1 over square root of 1 minus t square is sine inverse t, and the limits are from -1 to 0, right? So now substituting the limits here, we can write, and this is square root of 2, and if we substitute t equal to 0 here, we get sine inverse 0 minus, and here we have sine inverse minus 1, right? Now the value of sine inverse of 0 is equal to 0, and the value of sine inverse of -1 is equal to minus pi by 2, right? So the integral becomes I is equal to square root of 2 multiplied, here we have 0, and here we have minus and minus pi over 2, right? So this is square root of 2 multiplied, minus and minus, the product becomes plus, so here we have pi over 2, right? Now multiplying the numerator and the denominator by square root of 2, so this expression can now be written as pi root 2 over 2 multiplied square root of 2 over square root of 2. So here we have pi over 2 root 2, and square root of 2 multiplied square root of 2 is 2, so 2 and 2 get cancelled, so we are left with pi over square root of 2, right? So the value of this integral is equal to pi over square root of 2. So this is how we solve this problem.